whatever you want. So let's go back to that. Connor, do you have that problem one more time for us?
1 second.
So, or maybe Caleb, do you have that?
Okay.
The problem? Yeah, you found it?
Yeah.
Okay, perfect.
A tumor is injected with 0.2 grams of iodine 125.
Okay. This is not important. This is just the name of the radioactive substance.
Which
Perfect.
decays at 1.15% per day.
Per day.
Write an exponential model.
So write the model in part A.
Representing the number of grams F of iodine 125 remaining.
Right.
After T days.
Okay, and then part B was find.
Part B was find what it was equal to after 90 days.
When T equals 90 days. Okay. I looked at, any questions, David?
No.
Yeah, okay. So there is absolutely no example in your text similar to this. So it doesn't matter, however, what we need to do is think about this percent. So this is the percent per day. It's not really, when we look at the model is M of T equals M0 e to negative KT. This is not the decay rate of iodine. It just says that the constant K, in other words, specific to iodine. It just says that this quantity reduces, whatever it is, reduces by 1.15% per day. So here's an example. I have $100 in my pocket, and I give you 10% of it per day. So how much money I have left after the first day? $90, okay? So in this way, we are going to create a point. So if we start with 0.2 grams, and we subtract 0.2, I shouldn't put the grams, there is no need for the measurement unit in the expression here. So we start with 0.2, and we subtract from 0.2, we subtract 0.0115 of it. It's like my example. I have $100 and I give you 10% today. So tomorrow I have $90. So, bless you. So we start today with 0.2, like with $100. And tomorrow I have $100 times, so subtract $100 times 0.10. So at the end of the first day, this is what we have left. So this is after 1 day. We're going to calculate this in a moment. So we just created a point. 1 day, comma, give me that answer, please. Or I will. So it's 0.2, basically, subtracted 0.2, is 1.15% of that. 0.0115. So I got 0.1977. Is that correct?
Yes.
So 0.1977 grams after 1 day. This is what we got. Let me shut the door. Good. So this is our point, 1 comma that quantity. This is the point that we want to put in the model. So every point of a model represents when this is x, this is f of x. In this case, when this is t equals 1, this is m of 1. So what we get is 0.1977 equals m sum 0, which is, I should replace it, 0.2 times e to negative k times 1. So do we understand this step?
So you could have used any other point, right?
I can use 0.2 comma whatever. Yes.
Would you not have used 0?
So if you want to use 0, you just get 0.2. So it's 0 comma 0.2. So you're not going to get anything else. So from here we will solve for k. If you have 0 here, it's a very good question. If you have 0 here, you're not going to determine k.
You can't solve k.
Yes, that's the problem. So that's why you have to determine how much is left after 1 day. So we start with 0.2. After 1 day, the 0.2 becomes 0.1977. So I created this point 1 day, comma 0.1977. So when the function is m of t, when the function is this, the t is 1. And this is the equation we get. Is this clear so far? Okay, then, of course, we will divide by 0.2, so 0.1977 divided by 0.2 equals e to negative k. And now I know this is an exponential equation, and I will be able to solve for k. How do I solve for k? What do I need to do? Excellent. So apply natural log to both sides. So then I have natural log 0.1977 over 0.2 equals negative k. So then k will be the opposite of natural log 0.1977 divided by 0.2. You know what I mean. I'm rushing. I don't have to rush. So it's natural log everything divided by -1, but it's the same thing. Okay? So it's this multiplied by -1. Now, I think we looked in WebAssign, and I think they were asking us to simply, because they want an exact number. I don't know why. There is no need for an exact number. So let's divide these two and write that k equals that number with minus in front. So when we divide what we had, divide that by 0.2, what did I get?
8.105.
0.9885, correct?
What did you do?
I divide 0.1977 by 0.2 to just one number instead of this fraction.
Oh, right, because they didn't actually finish solving.
No. So then k equals the opposite of natural log of 0.9885. Is this okay so far? Now we put this back in the model. S is, because they want an exact number. So the model now is m of t equals m0, which is 0.2, times e, to natural log, because there is a minus in the model and there is another minus in front. So this will be natural log of 0.9885, everything multiplied by t. Okay, there is no need for this. You can approximate. That will be fine. But they want an exact number.
Would we come across something like this in a test, or is this only for the one time?
Why, what happened to the negative?
There is a negative in the model.
Okay, so it's impossible.
So there is a negative in the model, correct?
So negative.
And there is a k which is negative. So those two negatives will come out to be
Oh, right.
this will be a negative number anyway.
Right.
Okay, so this is the model. And we're done with the first part. Now in part B, we're asked to find, what was it, of 90 days. So m of 90. Now I have no choice. I have to put in the calculator because no matter what you do, you can determine this. So 0.2 times e to natural log 0.9885, close the parenthesis, multiply by 90, and close the parenthesis. So it will be 0.0706. I don't know how many decimal digits they want. I'm assuming maybe 2. So it will be 0.07. The measurement unit was grams, so this is grams.
Thank you.
Thank you. So that's a little catch here, I would say.
Did you say this wasn't gonna be like this? I mean, the test.
That's all we care about?
I mean, it does support my head.
Okay, the next question. Next question. Yes, baby? Yes, I'm ready.
Well, it's kind of like a question too, like, because
Yes?
the problem was.
So I wanted to address this because I'm not sure whether everyone got to 6.7. So I didn't want you to have any difficulties when you get to those problems. Thank you so much for being so advanced and showing this to me. Yes, David.
The area of a,
Yes?
a sector of a circle with a diameter of 20 feet and an angle of 3 pi over 2 radians. And it wants us to find the area of the sector in feet squared.
Okay.
And so, like, I know.
So first let's write that this is 1/2 r squared times theta.
Wait, I have a question.
Sure.
So, like, I got that as like the formula, but when I did it that way, it was wrong, and it was trying to tell me that the formula is 1/2 theta r squared. Is that the same thing? But theta and the r squared switch.
2 times 3.
Yeah.
3 times 2.
No, but there's a 1/2.
Okay. 2 times 3 times 4. 4 times 2 times 3. 3 times 4 times 2.
What was
That's all it's saying.
Okay, but I got wrong with this.
Okay. What is the radius?
The radius is 10.
So the area then equals 1/2 times 10 squared times 3 pi over 2. Is that what you wrote?
Yeah.
Yes?
Yes.
Now what did they say? Approximate this. Don't approximate. Exact. What do they say? Because,
They rounded for that whole place.
okay, so when we divide by 4, right, we get 20. So this is 60 pi in whatever, feet squared. 25, sorry. Right? 25, so this is 75. So what was the problem? What do you think? So 75 times pi. Is that what we wrote?
Yeah, I ended wrong.
This one?
Oh wait, never mind. I'm just kidding. Okay.
Is that okay now?
Yeah, yeah.
So 235.62 square feet? Is that correct? Okay, perfect. Other questions? Next question. So this is approximately then 235.62 square feet.
And that's just solving the arc length.
This was the area.
Area.
This was the area of the sector. In other words, it's something like this. So this is 3 pi over 2.
Which row is on the top?
It's this area with a radius of 10 feet. That's 3 pi over 2. 3/4 of the circle. Okay, anything else? Is there anything else?
7.1.
Is there anything else? I thought there were more hands up for questions. Nothing else? Yes, please, Glenn. Yes, Glenn.
7.4.
Yes.
It says if secant of t equals 5.4, what is the exact value of secant of negative t?
Since secant is one of the two trig functions that is even, secant of negative t must equal the same number. Secant of t. It's one of the two functions that is even.
And you can't just solve that algebraically. You guys have to know that.
Say that again?
You guys have to know that. I mean,
Yes, you need to know that two functions are even, cosine and secant. And all the other functions have sine in them, so they're odd, right?
So, when it's even, like, no matter what, even if it was cosine,
Yes.
it's gonna be the same as when it's odd, then you have to solve it out algebraically.
No, when it's odd, we put a negative in front. That's what it means, by
it's
odd.
okay.
F of negative x is negative f of x for odd. And f of negative x is f of x for even. So let's write this one more time. So f of negative x is f of x for even. And f of negative x equals negative f of x for odd.
Oh, okay.
That's the beauty, so you don't ever have to worry about negative angles. Okay, anything else? Yes, please, Flynn?
Sorry, just a question about.
Yes, please. Yes?
It's just use reference angle to find the exact value of the expression, tan of 300 degrees.
Okay, so let's do that. So we have tangent of 300 degrees. Any questions, please? Any questions? Any questions? Okay, we did this last time, if you remember. This is 60 degrees shy of 360 degrees, so this is 300 degrees. You know the tangent in the fourth quadrant? Sine is negative and cosine is positive, so the answer must be negative. So therefore, you have to write that tangent 300 degrees is the opposite of tangent of 60 degrees, because the reference angle is 60 degrees. And you have to put the sine first, knowing that in the fourth quadrant, sine is negative and cosine is positive. And now, since I mentioned that, I said, please don't sit there and find and memorize tangent of 60. It's a waste of time. Then you will say this is sine 60 over cosine 60. I know that this is the smallest angle. And then I flip and I combine and I get this. It will only take 5 seconds instead of memorizing it, which I don't agree with, but it's up to you. So you will always be able to determine tangent 60 as sine over cosine. Sine is the smallest, so I said the smallest, and it actually is the other way around. Don't let me make mistakes.
So if we, not for this particular question, but if we do put this in the calculator, do we have to change it?
You can't, because this is an irrational number. You will not be able to change it, to change an irrational number into a fraction. Because it's an irrational, it doesn't change into a fraction. They will not be able to determine
I mean,
this.
like when you're doing like another problem, like the triangle question.
Yes?
We have to change that.
Well, it depends. It depends. If you have sine of 80 degrees, you will not be able to determine something like this because you don't have numbers for those. But if it's anything like 30, 45, or 60, you have to use the exact numbers. But if it's anything else, you will not be able to. Whatever you get, it's good enough. So sine 60 degrees is square root of 3 over 2. Cosine 60 degrees, 1/2. When you flip, you get negative the square root of 3. Very good. Other questions? Yes, Flynn?
Can we do one with radians?
Oh, yes, of course. We did that. Did you look at the previous lecture? Yes, of course, we can. Yes, of course, yes. Yes, please give me a problem.
Secant of 3 pi over 4.
3 pi over 4?
Yes, ma'am.
Okay, pi over 4 is 45 degrees. This is the easiest angle to work with. So 3 of 45 degrees, 1, 2, 3. So that's where your 3 pi over 4 is. And you don't care about secant. This is 1 over cosine of 3 pi over 4. And you know cosine in the second quadrant is negative, so this is 1 over negative the square root of 2 over 2. Which is negative 2 over the square root of 2, and when you rationalize with the square root of 2 over the square root of 2, you get negative the square root of 2. So don't get scared or drawn back by gradients. You can always change it into degrees to see what it is. But this is actually the easiest possible type of angle, because it has pi over 4 in it. Because there are 2 pi over 4 in each quadrant, 1, 2, 3. If you have 5, 1, 2, 3, 4, 5, and so on and so forth. Pi over 4 is the easiest to work with. Now, since it's secant, and secant is 1 over cosine, and you know that cosine is negative in the second quadrant, so will be cosecant. So will be secant, negative. And this, as I mentioned also several times, pi over 4 is the friendliest angle you can come across. Because it has the same sine and cosine. Yes, Fran?
So this is just a general question.
Yes, please.
And you might have answered it already, but I'm also like kind of dumb, so we'll see. In any sort of situation, this like for this, the square root cannot be at the bottom, like in the denominator, no matter what.
So that is the general idea. However, I don't want to say always, because there are situations you'll see in calculus in which we have to rationalize the numerator.
Yeah.
But normally we need to rationalize the denominator.
Okay.
But I can't say forever, because it depends on the problem.
Okay.
So when we get to limits in next semester, you'll see that in some situations you have to rationalize the numerator in order to get something. So, but yes, in general, yes, we do not want radicals in the denominator, no matter what. Anything else? Anything else? Okay, I'd like to move on to the graphs of sine, cosine. So here's where we are, graphs of sine and cosine. And then we're going to look at the graphs of others, but mainly tangent. I'm happy with sine, cosine, and tangent. And then we'll look at the inverse functions. Any questions for me? Anything? Okay. So this is chapter 8. And we're going to focus on the graphs of sine, cosine, and tangent. Yes, I will show you the graphs of the other ones, but these are the most important ones that you will see very frequently. Okay, so let's look at the graph of f of x equals sine x. We'll also talk about period for each function. All trigonometric functions are called periodic functions. They repeat in chunks, identical chunks. And the chunk is a period. So on each side, I'm going to write pi over 2, pi, 3 pi over 2, and 2 pi. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Before we continue with the graph, let's take a look at this unit circle. And let's say this is a point, and this is angle alpha. And I'm going to ask you, what is the max sine alpha, and what is the min sine alpha possible? Where do we measure sine? On the y-axis. How big can sine be? 1. How small can sine be? I need that for the graph. Very good, awesome. So let's go around the circle, and I'm going to ask you a couple of questions. So let's look at the circle and tell me how much is sine 0. How much is sine pi over 2? Excellent. How much is sine pi? Sine pi. Very good. Sine 3 pi over 2. Sine 2 pi. Good. So the same thing on the other side. So here's the graph of sine. So this is the graph of sine x. And I do see the chunk that repeats itself. This is the chunk that repeats itself. So what do you think the period of sine will be? Where I see a chunk and which I see all possible function values. Between 0 and 2 pi, I see absolutely everything. That's the period of this function. The period is 2 pi. Okay, now we know that we are going to eventually talk about the inverse function. And you should say not possible. Because this is not it's not 1-to-1. If I cross it with a horizontal line, it will not be 1-to-1. Okay, stay with me because I'm going to make a change. What about this function? Is this function 1 to 1?
Yes.
So remember, between negative pi over 2 and pi over 2, we are going to create a new function. And that new function, we will say sine x is 1 to 1 on negative pi over 2, pi over 2. So sine, we'll say it's defined between negative pi over 2 comma pi over 2. And what is its range? We know the range.
Okay, 1 to 1.
Well, of course. What about the inverse function? Bless you. First of all, how do you think we're going to denote it?
As sine inverse.
Which does not mean 1 over sine, right? It really means the inverse function of that. Perfect. So now, sine inverse will be defined on, right, indeed, between negative 1 and 1, taking its values between negative pi over 2 and pi over 2. And yes, this was artificially determined. It doesn't mean that you cannot determine, let's say, a sine of, or cannot find sine 2 pi. You can, of course, it exists. But we needed to truncate, minimize the domain of sine so that the inverse function exists. Yes, please.
Since you're now making it 1 to 1, can I like shift it that way to get it to pi over 2 to 3 pi over 2? Because that could also work.
No, because I have to keep it odd as well.
What do you mean?
Odd function. An odd function is symmetric with respect to the origin. If I move this piece over here, it's not going to be symmetric with respect to the origin.
Okay, so it has to go through or
Yeah. Very good question, actually. Good. So again, this is artificially determined. Can I determine the inverse function of, and remember, this is very important, when we determine sine, sine has to be applied to an angle, and the answer is a number. But when we determine sine inverse, we apply it to a number, and the answer has to be that. An angle, but between negative pi over 2 and pi over 2. So you can still apply sine inverse, or you can still apply sine to negative pi over 2, pi over 2, and outside. But if you want to, in this context of function and its inverse, you have to stay within that. So these are set in stone, because otherwise the inverse function doesn't exist outside of that interval. Okay. Let's take a look at cosine. We'll come back with examples in a minute. So f of x equals cosine x. Same graph. Pi over 2, pi, 3 pi over 2, 2 pi. Negative 2 pi, negative 3 pi over 2, negative pi over 2. 0, of course, pi over 2, pi, 3 pi over 2, and 2 pi. Good. What is the maximum possible for cosine? Excellent. What is the maximum possible for sine? What is the minimum possible for cosine? Yes, of course. Same thing. Positive 1, negative 1. So let's go again around the unit circle. And at 0, how much is cosine? Very good, awesome. At pi over 2, how much is cosine? Excellent. At pi, how much is cosine? Excellent. At 3 pi over 2, how much is cosine? Excellent. And at 2 pi, how much is cosine? Good. So if you want to remember it, it's a shifted sign, but if you want to remember a complete period of it, it's like a vase, if you want to call it that way. So of course, on the other side is the same thing. And it continues forever on both sides. Now we have to truncate this domain. Obviously, this is in chunks again. So the period is still 2 pi for this function. But we need that chunk that makes it 1 to 1. So the period is still 2 pi. but we need that chunk that makes it 1 to 1. It gives us all the possible values. So then if we want to work with or define the inverse function, we will have to say, although we know that the domain of this function is all real numbers, negative infinity to infinity. The same thing for sine. The domain is still negative infinity to infinity, but we had no choice. We had to truncate the domain. And we will do here the same thing. So cosine is defined between 0 and pi, taking its values between -1 and 1, and the inverse function will be reversed, of course, -1 to 1, and the answer is 0 to pi. So every time we talk about the inverse function, we have to look at that. Okay, last function that I would like to look at, and the other ones we can graph also, is f of x equals tangent x. There is a problem with tangent. We'll discover the problem in a minute. So negative pi over 2, pi over 2, negative pi, pi, negative 3 pi over 2, 3 pi over 2, negative 2 pi, and 2 pi.
I have a question.
Yes, please.
So, going back to like the cosine. on that,
Yes.
Would it be wrong just to write all real numbers, but for the inverse, we actually have to write that?
Yes, because I'll give you examples in a minute. Yes, it's a very good question. Thank you. Yes, I'll give you examples. Okay, very good. So let's look at tangent. Tangent is sine x over cosine x. We did not see this in the previous two examples with sine and cosine because sine and cosine are not fractions. You can say, but they are. They are the opposite with the hypotenuse, yes. But they will never be undefined. The hypotenuse can never be 0, right? But here, cosine can be 0. Where is cosine 0?
Pi over 2.
Okay, so at pi over 2 and negative pi over 2, where else? Right, at 3 pi over 2 and negative 3 pi over 2. What does that mean? It's a vertical asymptote. Thank you. So tangent is not a friendly function. Tangent, like the other ones, cotangent, secant, and cosecant, they're not friendly functions. They join log functions, square root, or even roots, and rational. Okay, so what about that 0? Tangent 0. 0, very good. Tangent pi over 4, right here in the middle. We know that. At pi over 4, sine and cosine are the same, so we know tangent. 1, very good. So here's the graph. And of course, it repeats itself indefinitely. Is this function 1 to 1? Of course not. We have to truncate the domain, and we will truncate the domain between negative pi over 2 and pi over 2 without negative pi over 2 and pi over 2. And what is the period of this function? Between negative pi over 2 and pi over 2, which is pi. Okay, so let's look at tangent then is defined between negative pi over 2 and pi over 2 without negative pi over 2 and pi over 2. And can anyone give us the range of this function? Very good, awesome. What about the inverse function? What is the inverse function defined on? Yes, that is a friendly function, and it takes values between negative pi over 2 and pi over 2. Yes, Lauren, any questions? Do you have any questions? Okay, anyone? Questions? Yes,
So
please.
How we get period for, how we get period pi?
Yes. So this is pi over 2, and this is pi over 2. Pi over 2 plus pi over 2 is pi.
What's the formula for finding the period?
Very good. We're going to get to transformations in a moment.
If
Oh,
we
the formula for this?
Yeah.
There is no specific formula for this function, but there is something that we have to discuss for this function when we find its period. So let's talk about the period for all these functions. There are only two options, 2 pi or pi. In the pi column, only tangent and cotangent. Everything else has 2 pi. Sine, cosine, secant, and cosecant. So all functions have period 2 pi except tangent and cotangent. Those have pi. There is no specific formula for this. Just look at the graph. But yes, if we want to determine tangent, the period of tangent to x, it's a different story. And I would like to start with that since you asked. It's a very good question. You're way ahead of me. That's good. So we want to look, let's say, tangent to x to find the period. Let's say we want to find sine 1/2 x, the period, and give me maybe a cosine, whatever you want. 3x? Perfect. Okay.
So technically that would be some sort of shift in the horizontal. Instead, since we applied the x.
If you remove shift and you talk about stretching or shrinking,
Stretching, I mean, yes.
excellent. Excellent. I said that, right? A long time ago when we talked about horizontal stretching and shrinking. Okay. So when we change x into twice x, what happens? And here are the possible options. This, horizontal shrinking, or this, horizontal stretching.
shrinking?
Correct. Is the opposite of what you would expect. So therefore, the period for this is pi divided by 2. Exactly. So let's come back to this. What will be the period of this? So exactly. It's not a horizontal stretching, but it's a horizontal shrinking. In a minute, I'll explain one more time. So what about this one? It's still 2 pi divided by 1/2, but it changes into 4 pi.
Oh, I get it. Okay.
So be very careful when we replace or multiply x by a number greater than 1. The graph has a horizontal shrinking. Same thing here with 2 and same thing here with 3. The initial period is pi, but look, now it's half. The initial period was 2 pi, but now it's 2 pi over 3. For 1/2, you apply the same procedure. It's still 2 pi for sine, and you divide by 1/2. But when you divide by 1/2, the period becomes 4 pi. That is the best illustration of this horizontal stretching and shrinking, which we didn't have a month ago. But if you remember, I said, when we get to trig functions, this will become very easy to understand. But we didn't know trig functions at that time. Very good question. Anything else? I think you had another question that I needed to respond to. No?
So how we
Yes?
get 2 pi over 3?
Say it again.
How we get 2 pi over 3? Last one.
So whenever we multiply x by 3, all x values get divided by 3. Okay, so if we go back to that simple example from a month and a half ago, we said this is x cubed. But 8x cubed is this. And basically I changed x into twice x, which makes the graph to have a smaller period. So when I multiply x by 3, all x values get divided by 3. So that's why the period becomes smaller. Instead of being 2 pi, it will be 2 pi over 3. Better? Okay, other questions here? I'm sorry?
Why wouldn't it just be pi over 3?
Because if you look on the table over there.
Which one would be pi over 3?
Yeah.
Is that clear?
Yeah.
Okay, perfect. Okay, so at the end of 8.1, and that is on page 656, I would like us to choose, let's start with, let's say 14, and then we'll come back to answer more questions. Let's take a look at the following. So obviously this is not a pure sine function. It has transformations on it. It has a constant in front of x. It has some sort of horizontal shift. And it has a number in front. Correct? Okay. So this number is the amplitude of this function. What does it mean, the amplitude? It means max and mean value, exactly. So the amplitude, if this number is 1, the function goes to the highest value, which is, and the smallest value, which is good. What about if this is 3? It goes to the highest, which is 3, and the lowest, which is -3. But when we present the amplitude, this is always going to be a positive number. So we will have to write the absolute value of A, whatever that number is. So how high and how low it goes. Some people say it's, you add the maximum and add the minimum and divide it by 2. I just think it's the easiest to remember is how high it goes or how low it goes. However, the problem is that if I add here a different number, that's going to be a different story. So I do tend to agree with max plus min divided by 2. So we'll have an example in a minute. Okay, what about the phase shift? The phase shift in this case is -c. Because we know that if c is a positive number, right? If c is a positive number, the horizontal shift is called for trig functions phase shift. So it's the same thing with the horizontal shift, but it's called phase shift for trig functions. So in this case, if c is a positive number, the shift will be to the left. If it's a negative number, the shift will be to the right. And that doesn't change from what we know from before. What about the period? The period is still 2 pi because it's sine divided by b, whatever that is. And now having all this information, we are ready for this 14. So let's start with it. On page 656, and we have f of x equals 3 cosine 6/5 x.
Is it a negative?
3 cosine 6/5 x. So it's this yes, number. So it says, for the following exercises, graph 2 full periods of each function and state the amplitude, period, and midline, okay. State the max and the minimum y values and their corresponding x values on one period for x greater than 0. Round answers to 2 decimal places if necessary. Okay. So let's do just that. So first of all, let's identify the amplitude. What is the amplitude of this function? Is the absolute value of 3, which is 3. Because you may have negative. So you still have to put in the absolute value. Perfect. What about the period? We are talking about cosine. So then the period will be 2 pi divided by the number that multiplies x, which is 6/5, which will be 10 pi divided by 6. I will simplify by 2, and I get 5 pi divided by 3. Is this step understood? Yes? Okay, what about the phase shift? Yes, correct. Perfect. So now, many of these situations are not very friendly to graph, but we have to. For now, I'm fine if we just present one complete period. We don't have to write two, okay? That's fine. One is good enough. So what is this? Again, it's 5 times 60 degrees. So this is roughly 300 degrees, right? Pi over 2, pi, 3 pi over 2, and 2 pi. But I have to stop at 300 degrees, which is 5 pi over 3, which means 60 shy of 2 pi, right here. There's no vertical asymptote or anything. I just want to present the graph. The graph has to be between 0 and 5 pi over 3. Nothing beyond it. We're going to graph it with the graphic calculator as well. They're asking us to state the minimum and the maximum values. So what would be the maximum value for this function?
3.
Perfect. 1, 2, 3. 1, 2, 3. What will be the minimum value for this function? Perfect. Where does it start? When x is 0, cosine is? Very good, awesome. Remember, the graph of cosine has to look like a vase, right? So it starts at 0, 3. It has to end at 0, 3. At 5 pi over 3, 5 pi over 3, 3. Okay, right in the middle, exactly in the middle, it has to reach that -3. Correct so far? Okay, so let's see where is this middle. So 300 divided by 2 is 150. So this is pi over 2, and this is pi, and this is 3 pi over 2. Where will be 150? So 150 will be 30 degrees shy of pi, correct? Perfect. So that's where,
Can you just take the 5 pi over 3 and divide that by 2?
perfect, yes. Yes, of course. Okay. Now, where will it cross the x-axis? I don't know. I'd like to investigate. So I know so far the graph. There is no way around it. So this is definitely the graph. But I would like to see if I can determine where it crosses the x-axis. And that will be done. So X-intercepts. I write the function one more time here. 3 cosine 6/5 x. Okay. Where is cosine 0? So in order to find the x-intercepts, I would have to set 3 cosine 6/5 x equal to 0. Now, this one doesn't matter. I will divide both sides by 3 and I'm done with that. So now let's think. Don't look at anything. Just think in terms of cosine being 0. So cosine is 0 at pi over 2 and very good. So then we know that 6/5 x can be pi over 2 and 6/5 x can be 3 pi over 2.
Can you explain that again?
Yes? I didn't want you to look at this. Just think. Cosine of which angle is 0? Pi over 2 and 3 pi over 2. Because at 0 is 1 and at pi is -1. We're measuring cosine on the x-axis.
So you plotted both points.
Yes, I may need, because of
You have
that
to figure out which one.
because of that 6/5, I may have to go to even more than that. But for now, we'll see what happens. I'm expecting 2 solutions. I'm not expecting more than 2. So that's why I didn't go beyond that. Perfect. So is this clear, everyone? Okay, so then I will have to multiply both sides by 5/6 to get the first solution as 5 pi divided by 12. I'll do the same thing with the second one, and I multiply still by 5 divided by 6, and I get 15 pi divided by 12. Okay. How do I find these on, because we are asked to approximate them, right, and see where they are. How do I find these? I'll have to put them in the graphing calculator and see where they land. And all I really need is not involve the pi. Just divide these two and see where it lands. So then just divide these two and see where it lands on the x-axis. I don't need the pi. So let's do that. So when we divide 5 by 12, what do we get? And this will tell me how far away from pi this is. And then 15 divided by 12. This is 1.25. Okay, so here they are. So approximately 0.42 pi, and approximately, no, this is exact, 1.25 pi. Okay, so here's pi, only 0.42, half of pi, a little bit less than half pi, so somewhere here. The other one is 1.25 pi. So pi this is it. They have to be symmetric. They have to be the 2 points have to be symmetric with respect to the minimum. So now we can graph this with the graphing calculator if you wish. Make sure that your mode is in radian mode. Let's go to y equals. Clear if you have anything else. And we put in 3 cosine in parentheses. It was 6/5. Careful how you put that. I would put 6x divided by 5. Or put enough parentheses, otherwise the calculator will just... Sorry about that. Otherwise the calculator will do something else. So 3 cosine 6x divided by 5. Or you put 6/5 times x and 2 sets of parentheses, which I don't recommend. Okay, now we have to adjust the viewing window. I only care to see between 0 and 5 pi divided by 3. I care about a unit, let's say, of pi over 3 or pi over 6, it doesn't matter. I only care for -4 to +4 with a scale of 1. And I'm ready. It has to show the entire complete phase, coming from +3, going from +3 to -3, right here in the middle. This is that 0.4 pi, and this is that 1.25 pi, and we can determine them also with the graphing calculator. We determine them by hand, but with second and calc, we can go to 0. And I want this 0 between 0 and pi over 2. So between 0 and pi over 2. Oops, I didn't mean that. So one more time. I want the 0 between 0 and pi over 2. Perfect. We passed the 0. That's all I care about. And this has to be that 0.4 times pi. Can anyone calculate for us? What we had 0.4. We had 0.42 times pi. Can anyone calculate 0.42 times pi? And we have to get 1.30899. We can determine the other one as well, and it will be 1.25. If you can calculate 1.25 times pi, and we'll determine the other one. We want a 0, and we want between pi and 5 pi over 3. Why not? And the answer has to be 1.25 times pi has to be 5.23598. I'm sorry? I don't want to guess. I thought I already pressed. Sorry. Thank you. So the answer has to be 3.92699 of 1.25 times I. Of course, a little bit of error because we truncated the number, so. Any questions on how to graph a cosine of this kind?
I have a question.
Please do.
So, when you find the x's,